Hello everyone, this is Read One Titian. Please, if you are new on this channel, before you leave, ensure you like and subscribe to my channel. Thanks a lot. So let's move to the topic of today. You know, have you ever wondered? Why steel is the only reinforcing material we use for concrete? There are several materials. We have gold, there is copper, we have iron, there is aluminium, and other metals and alloys. Of course, we can't use gold because everyone knows that gold is expensive, and it will be so uneconomical to use it for just reinforcement of concrete. Why? Like, who does that? Who? So, but if it is not gold, okay, fine, it can be gold. So why can't it be other metals, other materials, fibers? I don't care, any kind of material. So, for example, now why can't it be iron? Iron, we all know iron. Steel itself is an alloy of iron and carbon. So why can't we just use iron, which is the original form of steel, to reinforce concrete? Why do we need to alloy it with carbon before you can use it? I don't get. So I've been curious as well, so I made some researches which I'm going to share with you today. But before I do that, I want us to recap on why do we even need to reinforce concrete at all. This is different from the main topic. The main topic is, why do we need steel? Why do we use steel? Is steel the only material? But before then, I want us to talk about why we even reinforce concrete at all. So let's get started. There are three major reasons to why we reinforce concrete. Three major. They are just major. We have several reasons, but major ones. So number one is to increase the shear strength of the concrete. We want to increase the shear strength of the concrete. Number two, we want to increase the tensile strength of the concrete. And number three is we want to increase the compressive strength of the concrete. These three strengths are so important in concrete. If you have a concrete that lacks all these three properties, then you are playing with failure. So that's just it. There are several reasons, as I've said, but the three major are the one I've mentioned. There are others, like to prevent cracking or to reduce cracking, let's say it that way, to prevent sudden creep or sudden failure. That's the part of it. Okay, so this is what shear failure looks like. Yeah, this is shear failure. This is a beam that is undergoing shear, or a beam that has undergone shear already. It has undergone shear already. So this is the shear plane. Look at this diagonal plane. Look at this diagonal plane. This diagonal plane. See this? Yeah, that is the shear plane. You can see the part of the beam. The part of the beam at the right is trying to slip over this part of the beam at the left. So this is what shear failure is. So this beam has undergone shear. Why? Because it lacks shear strength. There's no shear strength, or let me see, there is limited shear strength to it. Of course, there is no reinforcement in this beam, so it is a mass concrete. So it lacks shear strength because there is no reinforcement, and this is what we don't want to happen to our beam. So that's why we want to reinforce our beam. So the shear strength is too small, or let's say the shear stress that is being induced in this concrete due to the load, the external load, is greater than the shear strength of the concrete. So that is why it is undergoing a shear failure right now. So that's shear. Now, so we shall discuss what the compressive strength and the tensile strength is. So look at this beam. This is an overhanging beam that is being supported by two columns, and it is loaded centrally. So now what will happen to this beam if we increase the design load by just a little bit? So let's see what will happen. Okay, so this is that same beam. This is that same beam. You can see that same beam, but what has happened to it? Look at it. You can see that here, look at this top fiber, the extreme fiber. You can see that that's deflected. It has deflected, and therefore it has reduced in length, meaning it is in compression. So look at the bottom. It has what? It has also deflected, and it has increased in length, meaning what? It has experienced tension. So the stress that they are experiencing respectively for the first one is for the top one is the compression, and for the bottom is the tension. So you need what? For the top, you need compressive strength to cater for or to resist the compressive stress. So for the bottom as well, you need you need a tensile strength to resist the tensile stress. So that's what tensile and compressive strength are all about. So what do you do to prevent that? Of course, you know that's reinforcement. Yeah. So you just need what? Let's zoom in. So it means you need reinforcement. So this is reinforcement. This is a reinforcing bar. This is a reinforcing steel. So it is made of steel. You can see it here. So let's look at the surface. So here you have 3 longitudinal bars at the bottom. You have another 3, then 3 at the top too. This let's discuss these 3 at the bottom and these 3 at the top. Okay, so you see these 3 bars, these 3 longitudinal bars. I mean this, and this. They are to cater for the tensile strength of the beam. So if these 3 are there, they will cater for the what? They will cater for the tensile strength of the beam. And you see these 3 at the top, this 1, this 2, and this 3. The 3 longitudinal at the top, they are to cater for the compressive strength of the beam. And you see this stirrup, the link, this rectangular steel that is surrounding them, this stirrup, that is to cater for the shear strength. Okay, now, so why do we need to use steel? Why not other materials? Why not, other different kind of material? There are 5 reasons to that, according to me. According to me anyway. There are 5 reasons to that. Number 1, steel has high tensile and compressive strength than others. It has a lot of tensile and compressive strength. And as you've confirmed, what we need is what? Tensile and compressive strength, and also shear strength. So we should go for a material that has high tensile and compressive strength. So definitely we have to go for steel, right? So its coefficient of thermal expansion is approximately equal to that of concrete, meaning if there is strain, the expansion of the steel will be equal to the expansion of concrete. So they are very compatible. So that's another advantage too. So we have to choose steel because of that. And number 3, it is cheap and recyclable. Wow. It can be welded easily if you don't want to use binding wire. So if you don't want to use binding wire, you can weld it. So it is easy to weld and unweld. So, and number 5, it is readily available in the market. So of course we have to choose steel because of these reasons. That's a good reason. So, but what about iron? What about iron? I said iron is the original form of steel. Why not iron? So the reason why we can't use iron is, number 1, iron is too heavy. See, iron is too heavy and we result so iron is too heavy and will result in increase in dead load of the concrete. So we don't want to use iron because of this. We are too heavy. So number 2, iron possesses impurities which could cause carbonation and reduce the mechanical property of the concrete. So because of this, we don't want to use iron. So I believe with all this you've learned a lot from this. So please don't forget to subscribe and like my channel. Thanks a lot. You're wonderful.